But please pause the video and get these notes down. We'll go ahead and solve some equations here that have square roots in them. So we have something like the square root of x plus 5 is equal to 6. Okay? Our first step, if you look back in the notes, says to isolate the radical. No problem here because the radical's already isolated. The second step says to raise both sides to the index power. Now the index here is going to be a 2. This is the square root that you've known for a long time. And we're just now introducing that concept of an index. If the index is not written, it's understood to be a square root or an index of 2. And you may have had that intuition anyway. To get rid of a square root, you're going to square it. But those do cancel each other. And you have x plus 5 is equal to. Now, to get the x out from under the square root, there has to be some kind of compensation for that. The compensation is had to square the other side, so it's now 36. And from here, step 3 is to solve. Step 2 is to raise it to the index power. Step 3 is to solve. And we see here that x is equal to 31. I can always go back and plug that in to make sure that it works. X is 31 in this case. I'm going to go ahead and do 3 consecutive examples. Of course, you can pause the video at any time. If I'm going through it too quickly, just pause and get caught up. But let's do one with a cube root. So we have 4 times the cube root of x minus 2 plus 5. And we'll say that's equal to, let's go equal to 13. And this one requires some more steps. Now remember, my strategy here is to get x, or my goal is to get x by itself, so I have to have some kind of strategy. I've got to get x out from under this radical somehow. The only way I can do that is to first get rid of the stuff that doesn't belong or pertain to the radical at all. This is 4 and 5. It may help sometimes to box in what you want to isolate. Step 1 again, isolate the radical. I've got to isolate that box. So we're going to subtract 5 first because it's farthest away. So 4 times that box that we're trying to isolate is equal now to 8. Again, the 4 has nothing to do with the cube root. I'm going to divide by 4. I've got the cube root of x plus 2 now equal to 2. So looking a lot better here that the radical's by itself. Now that we've got it by itself, we can deal with it. And to deal with the radical, I need to raise both sides to the index power. In this case, it's a 3. Let's cancel. 2 times 2 times 2, that's 8. A lot of times people get in a hurry and they'll hastily say 6 because 2 times 3 is 6, but this is a power, it's 8. Our final answer will be 6. Again, to check that, you want to take it and plug it back in to make sure that it works, and it will here. Do 2 more examples. I'll stop the video after this third one. Number 3 here. Sometimes you'll see 2 different radicals. Say x plus 5 is equal to the square root of 2x. Okay, if there's 2 radicals, at first glance you may think this is getting a little more difficult, but really it's not, because in your quest to get rid of one radical, you're going to get rid of the other one as well, because you do the same thing to both sides. So both radicals disappear simultaneously. Step 1 wasn't necessary. Isolate the radical wasn't necessary here. We went straight to step 2, which was to raise it to the index power. And now this is something you've solved for years. And you get a nice satisfying answer pretty quickly here. X equals 5. An answer again, or a solution here that you can easily check to make sure that it makes the equation true. And one more case here. This is a case where we have a radical isolated, but we have an x on the other side. So this is going to be the most difficult case. Again, we don't have to worry about step 1 here. The radical's already isolated. So we'll go ahead and raise it to both sides. Raise both sides rather to the index power, which here is 2. Now remember what we're doing to both sides. We're raising both sides to the second power. So I need to enclose this in parentheses because the entire side is raised to that power. Now the left-hand side, life is going to be easy for us. This is just going to make negative 14x plus 2. radicand, which is the inside part, just comes out of there. Over here, however, we have to square it. Now, a very common algebra mistake would be for folks to try to distribute an exponent into a sum or difference. You can't do that. This is not x squared minus 9 or x squared plus 9. You have to write it out. We're going to FOIL this out here. And for the sake of space, I'm going to go ahead and give you the final answer. You would have gotten here x squared minus 3x plus 9, but those negative 3x's will combine to make negative 6x. You may want to stop the video and check to make sure that you can get that value. But what do we have here? We have a quadratic equation. And this is going to require us to generally get a 0 on one side and then either use factoring or the quadratic formula to solve. So I'm going to try to get 0 here. I'm going to move everything over to the right. We really like our x squared term to be positive if we can help it. And most of the time we can help it, so we're going to do that. I'm going to make this side be 0 because these both cancel. This is x squared plus 8x plus 7. All right, so this one looks like it's going to work out well for us because when I have a situation like this where it's a quadratic remember means highest power 2, trinomial, first thing I generally try to do is factor, and it most always works. So you can see how the skill of factoring is never going to leave you, or always going to be used. Okay, it may leave you, and if it does leave, you need to get it back. We always need the ability to factor here. I get x plus 7 times x plus 1 equals 0. If I solve both of those, you're going to get x equals negative 7 or x equals negative 1. And you do have to be wary here in that when we test these, they need to both work. If one of them doesn't work, which is often the case, we want to throw it out. So if I take negative 7 and plug it back in, negative 14 times negative 7 is going to be positive 98. 98 plus 2 is 100. The square root of 100 is, well, is it negative 7 minus 3, which is negative 10? No, it's not. When we're taking the square root of a number, we want it to be just the positive of that number, not the negative. We don't say here the square root of 100 is plus or minus 10. We don't say that. When we say the square root of 100, we mean 10 only. It's only when there's a variable in here that you're trying to solve for that you ever introduce the plus or minus operator. So negative 7 is actually no good here. Hopefully the negative 1 will be. Let's check it. If I take negative 1 and plug it in, negative 14 times negative 1 is positive 14. 14 plus 2 is going to be 16. The square root of 16 is going to be positive 4. And again, I'll take negative 1 and plug it back in. This is somewhat of an unusual case. Actually, both of these don't work. Usually, the most often case here is that one of these two are going to work and not the other. Sometimes both of them work, sometimes neither one of them works. In this case, it's no solution. So this was a little unconventional, the example I showed you here, but you see the process. I mean, if you can emulate that process and just remember that to check it, as long as it works out to where the square root of something is positive, then it's going to work, which is most of the time. So on your worksheets and quizzes, you're probably going to get one of those two to work.